Hello, this is Mrs. Ross, and this is 2.7.6 Function Algebra Review Practice. This is basically your review for the test on Thursday. So the first question is this function a one-to-one? Why or why not? So if I draw my pencil and I roll it this way, this is called the horizontal line test. It only hits 1 point. Oh no, it doesn't hit, because it hits right here, it's going to hit 2 points. So the answer is no, because it does not pass the horizontal line test. Over here it says use the graph of the function to answer the question, determine the domain and range of the function. So we're still talking about this function over here. Keep in mind our cousins from Arkansas, Dixie and Roy D. So we know that domain is x. Okay, so everything x can be. So it starts over here at -2, but it doesn't include -2. So I would write that like that. And it goes all the way to 5. And it includes 5. Now, if I'm going to write this in the set notation, that's going to be x can be everything from -2 up to and including 5. Okay, let me change colors here. And then for range, we're looking at y. So we know our lowest y here is -1, and that's not included. And our highest y, 1, 2, 3, is 3, and that is included. So if I were going to write that in the set notation, y is everything from -1 up to and including 3. Find f of g of x, where f of x is that and g of x is that. Okay, so f of g of x means f of 1 over x, -1 over x, my bad, -1 over x. So I'm going to put this in there, okay? So I have 1 over -1 over x plus 1. And I need to simplify this somehow, so I'm going to multiply that 1 by x over x. I get 1 over -1x plus x over x, 1 over. What I did was I basically divided, so I said 1 over 1 divided by -1 plus x over x. You do keep, change, flip, and you get that. So I left this part out. You could also write this. This is correct. This is the answer. But you could also write it as x minus 1, so that the negative's not in front. It's the same exact thing. Okay. Let's pick a different color. I'm going to draw a little bit of a line here. It says find the domain, so I know that the domain is x of f of x divided by g of x, when f of x is that and g of x is that. So f of x divided by g of x, square root of x plus 2, 3 minus x. So the domain of f of x is that x has to be greater than or equal to 2. So, or -2. Because whatever makes this 0 or less than 0. So it can be equal to -2, but it can't be less than -2. So that's going to be my domain of f of x. My domain of g of x is that it can't be 3. Has to be greater than, or equal to 3. So we could do this to this infinity. Nope. The only problem is that when I put it here, it can't equal 0. So I'm going to have to take the equal to part off. So it actually can't equal 2, 3. Or else that makes this 0, and that's not good. So my domain for f of x over g of x is going to be -2 to 3. Okay, let's see. Determine if that and that are inverses of each other. If they're not inverses, explain why. Okay, so the way we know this is an inverse is if f of g of x is equal to x, then it's an inverse. Inverse. Okay. Okay, so that's f of 5x minus 1 over x plus 4. That means this entire thing is going to go not only here, but also there. It's pretty ugly. So let's see, 4. And what you might want to do is you might want to pause the video and see if you can work it out, and then come back and take a look at my steps, because this is super boring right here. I'm going to multiply this by x plus 4 over x plus 4, so we have a common denominator, and I'm going to distribute this 4, so I get, oops, I don't get that. I get 4 times 5 is 20x, 4 times -1 is 4 over x plus 4, all of that, minus 1, over 5x minus 1 plus 5 minus 5. That's a minus 5. Okay, there's another. Why can I not? That's minus. That's plus 1. That's minus 5. Okay. That's minus 5. So this is minus 5 times x plus 4 all over x plus 4. Okay. So up here, we have to multiply by x plus 4 over x plus 4. So we get 20x minus 4 minus x minus 4 over x plus 4 over 5x minus 1 minus 5x minus 20. Oh, wait. Over x minus 4, x plus 4. So these are going to cancel out. We end up with, and then let's see if we can combine some terms. So this, is that supposed to be minus x? That's plus 1. So that's plus x. So that's 21. My bad. 21x minus it's nothing. So these are going to cancel. And I get 21x. Here on the bottom, the 5x's are going to cancel. And I get negative 21. So my answer is negative x. So no, these are not inverses. I'm going to erase this, and then we'll do the next one. Okay, so this says find the domain and the range of the inverse of f of x if f of x is this. So here's what I know. I know that I'll put this up here, the domain of f of x is equal to the range of its inverse. Okay, so let's find the domain of f of x. So I know that 4x plus 7 can't be equal to 0. So I get that x can't be negative 7 over 4. So my domain is going to be negative infinity to negative 7 over 4, union negative 7 over 4 to positive infinity, which will be my range. Then I have to find the inverse. Okay, I'm going to erase this part right here so I have some more room. And I think I'm going to change pen colors because I'm bored. Okay, so we've got y is equal to 2x plus 5 over 4x plus 7. I'm going to have to switch the x and the y. X is equal to 2y plus 5 over 4y plus 7. We're going to multiply both sides by this, and you're welcome to pause this and see if you can do it on your own. Okay, I'm going to distribute. Okay, I need to get my y's on one side, so I'm going to subtract the 2y, and I'm going to subtract the 7x. I'm kind of combining steps here, so we end up with this. We're going to factor out a y, and then I'm going to divide. So my my inverse is, okay, and I know that the range of that is this, okay? My domain of this is that 4x minus 2 cannot equal 0. The denominator can't equal to 0. So I get x cannot equal to 1/2. Lord have mercy, where did I put it? Doobie-doobie-doo-doo. I don't know if I did. Okay, so my domain's going to be negative infinity to 1/2. Union positive infinity, or positive 1/2 to positive infinity. Okay, doing two parts here. I'm going to get these done. And then. Okay, so it says determine if this is 1-to-1. Choose the answer that best explains your reasoning. When we're trying to determine if this is 1-to-1, you can always graph it, or what you can do is you can plug in x1 and x2 and see if they equal one another. So the first thing I did was I multiplied everything by -1 so that this would just be square root of 3x1 minus 27 equals square root of 3x2 minus 27, and then I squared everything, and I got 3x1 minus 27 is equal to 3x2 minus 27. If I add 27 to both sides, I get 3x1 is equal to 3x2, and then if I divide by 3, I get x1 is equal to x2. So it is 1-to-1, yes, because x1 and x2 are equal to each other. Let me pick a different color, see if we can get one more done. The inverse of this, so we have y is equal to negative that. We're going to swap those. So I'm going to multiply through by a negative again. So I get negative x is equal to square root of 3y minus 27. And then I'm going to square them both. So I get x squared is equal to 3y minus 27. Let's take this up here. I keep running out of room. Same thing. Nope, it's minus 27, not plus. So that's 27. X squared plus 27 is equal to 3y. So I get x squared over 3 plus 9 is equal to y. And let's see. My constraint is that x is less than or equal to 0. All right, this is going to be part 1. We'll have to do part 2 on another video.